Hi guys, welcome to video 1 where we are going to recap and look at the topic of surds. First thing that I want you to think about is what actually is a surd. When you hear that word, what does it make you think of? Well, a surd is something which is written inside a root and is irrational. So it's written inside a root, like a square root or a cube root, and it is irrational. Okay, you may not recognise that word irrational other than in the sense of somebody, their personality being irrational, but in terms of numbers, the next question we need to ask ourselves is, what is a rational number? Okay, so a rational number is a number that can be written as a fraction. So a rational number is a number that can be written as a fraction. So I'm going to give you some examples of some rational numbers, and I'm also going to give you some examples of irrational numbers. Okay, the number 2 is a rational number. It's a rational number because the number 2 can be written as 2 over 1 as a fraction. Same as the number 8 over 2 is also a rational number. It's written as a fraction, but it could also be written as 4. Another rational number is 1/3. It's rational because it's written as a fraction, but I know as a decimal it's 0.3 recurring. Thinking about recurring decimals, 0.3131 with the recurring part above the 3 and the 1, so 313131, is also a rational number. It's rational because I can write it as a fraction. We have looked at before converting recurring decimals into fractions. That's something we will again look at in the future. Okay, irrational numbers. Pi is an irrational number. It is a number that cannot be written in any other way. It is just pi. As a decimal, it is a number that goes on forever. There is no pattern, so it is irrational. Another example is 0.30300300, and so on, repeating that pattern with a number 3 and then an increasing number of digits of 0. That cannot be written as a fraction. So what we want to ask ourselves is the square root of 81 a surd? Well, it's written inside a root, so we would think yes. But the next question we need to ask ourselves is it irrational? Well, I know the square root of 81 is 9. I already know that the square root of 81 is 9. Can 9 be written as a fraction? Yes, it can, 9 over 1. So root 81 is not a surd. Same with the cube root of 27. It's inside a root, so I think it might be a surd, but I need to check. Is it irrational? Well, the cube root of 27 is 3. 3 can be written as a fraction, which is 3 over 1. Okay, what about root 5? Can root 5 be written as anything else? Well, I can't square root 5. If I typed that into my calculator, I would get a really, really long, complicated number. So I don't think that that is a rational number. I'm just going to type it into my calculator and check. Okay, when I type that into my calculator, you'll see I just get root 5. And when I press this S to D button, I get a very, very long non-recurring number. So root 5 is an irrational number. So root 5 is a surd. Okay, so again, it's written inside a root and it's an irrational number. We're going to learn 3 rules of surds, but we're also going to look at a number of different things that you could be asked to do with surds. The first rule is that multiplication of 2 surds is the same as multiplication of the numbers within the surd. That sounds a bit confusing, so I'm going to demonstrate it for you now. Okay, so one thing I could do, method 1, is I could do the square root of 4, which is 2, times by the square root of 9, which is 3, and that would give me 6. Okay, but I also know that square rooting 4 multiplied by 9, which is the square root of 4 times 9 is 36. Square root of 36 is 6. Okay, so the first rule, rule number 1 that you need to write down and make really, really clear is that if I'm multiplying 2 different square roots, it's the same as square rooting the multiplication between them. Okay, I'll show you again because those 2 weren't surd values. I just used those as ones that I could work out so I could prove to you that it's true. The square root of 2, if I typed it in my calculator, that's not a rational number. It doesn't come out as a whole number or a fraction when I type it in. Same with the square root of 8. Okay, so I'm going to do the square root of 2 times by the square root of 8. Okay, and that's the same as the square root of 16, which is 4. Okay, it works the same for division, so also within rule 1, I want you to write down that the square root of 1 third divided by the square root of another third is the same as square rooting the division. So for that to be a little bit clearer. Okay, same thing works here. If I've got the square root of 8, which is a third, divided by the square root of 2, which is also a third, I can just do the square root of 8 divided by 2, which is the square root of 4, which is 2. Okay, so that's the most important rule that you need to remember about surds. It is the one that we use in all the other techniques for surds. You can multiply two separate surds or divide two separate surds, and it's the same as square rooting or rooting whatever calculation it is that you've done, multiplication or division. Okay, what happens if I get a number that I cannot simplify? Okay, so let's do it the first way that we said. I'm going to square root 3 times 4, which is the square root of 12. On all my previous answers, I got a whole answer. I got a 6, a 4 and a 2, but this time I've got something that I don't think is a rational number. It's a surd answer. Well, let's go back and let's try this technique. Anything that I could simplify if it was a square root, I'm going to try that instead. So method 2, root 3 is irrational. That's a surd. I'm going to leave that as it is. But root 4 is 2. So I've got root 3 times 2, which is 2 root 3. Well, I've got two different answers there. I've got root 12 and I've got 2 root 3, and they're both the same answer to this original question, root 3 times root 4. So we're going to need to think about a skill that I can do to get from this form into this form. That's what we're going to look at next. Just want to do one more example with you. Root 5 over 9. So this time I'm starting with it in the whole surd form, and I want to separate it into two separate surds. The reason I might want to do that is because I can spot that 9 is a square number. Okay, so I'm going to separate it out into root 5 over root 9 because I know that I can split it using this rule here, and then I end up with root 5 over 3. Okay, if any of that does not make sense, please do pause the video, rewatch it, and if you have any questions, please stop here and drop me an email. Okay, so why do I need to be able to use those rules? Well, the first skill that we're going to look at, the first type of question that uses that, is a question that says simplify the square root of 50. Okay, as we go through this topic, you'll notice that it is very much linked to square numbers. Okay, where before I had root 4 times root 9, they were both square numbers, so it gave me a nice number in the end. I ended up with root 16, I ended up with root 4, and it gave me some nice numbers. So anything that I can square root, so a square number, is really important. So before I do anything, I'm just going to write my square numbers out. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81 and 100. I'm just going to go up to 12 times 12 because they're the ones I think are most likely to come up. Okay, really important that you write this down. When you are simplifying a surd, you are looking for the highest square factor. Highest square factor. So I'm looking to use this rule, the fact that I can split a number that is into a multiplication, so into its factors, and then I can split it into two separate multiplications. So I'm going to go from this form into this form to try and simplify this 50. Okay, I'm looking for the highest square factor. So I'm looking for numbers that multiply to give 50, and I know that they need to be, or one of them, sorry, needs to be a square number. So I'm going to write out everything that multiplies to give 50. 1 times 50, 2 times 25, 3 doesn't work, 4 doesn't work, 5 times 10, I think that's all of them. Yes, it is. Okay, going through this list, I want to underline any that are square, and then once I've found all the square ones, I need to identify which one is the highest square. Not square, not square, that one's a square, there are no others. So the factor pair that I'm going to use to simplify the square root of 50 is this pair here. Okay, using this rule, I know that I can write root 50 as a multiplication of 25 times 2. You'll notice that I wrote the square number first. It doesn't have to be written that way, but it is a little bit more useful if you write the square number first. Okay, so I've got it in this form, and I know that if I've got a square root of a calculation, I can split it up into the root of each individual part. The square root of 25 times by the square root of 2. Okay, well, I know that that's a square number, and I know that I can simplify that. So the square root of 25 is 5. So now I've ended up with 5 times root 2. Just like with algebra, if I can avoid writing the multiplication sign, I do. If I had 5 times x, I would write 5x. So here I'm going to write 5 root 2. Okay, going back through that one more time. I thought of all of the factor pairs of 50. I looked for the highest square number as one of its factors. I used that pair, wrote it as a multiplication. I used my rule here where I could write a multiplication as 2 separate calculations, root 25 times root 2, simplified anything I could, and then collected it together. I'm going to go through a few examples. Really important that you write all of these down in lots of detail, and if you have any questions, then please obviously do let me know. Okay, so another fairly similar one, root 12. I'm going to write down all the numbers that multiply to give 12. 1 times 12, 2 times 6, 3 times 4. Okay, there's only one square number there, which is 4, so I'm going to use this factor pair, 3 times 4. Again, I'm going to write it as a multiplication inside the cell. I'm going to write the square number first. Root 4 times 3, separate it out. Square root of 4 is 2. So I've got 2 times root 3, and I know I can write that as 2 root 3. That's my answer. You don't have to do this step here. You can just go straight from here to here if you find it easier. Okay, moving across, I've got the square root of 147. That's not a particularly nice number, and this is a topic that comes up usually, most of the time, on the non-calculator paper. So I need to start thinking about, from my square numbers up here, which ones of those are going to fit in to 147. Looking through, I think, well, it's definitely not going to be divisible by 4 because it's an odd number. Is it in the 9 times table? No, it's not. If it's not in the 4 times table, it can't be in the 16 times table. It's not in the 5 times table, so it's not in the 25 times table. 36, don't think so. 49. I know that 49 times 3 is 147. Okay, 49 times 3 is 147. If I would carried on writing out the factor pairs, I'd also have 1 times 147. 2 doesn't work. I've got 3 times 49. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 does work. 7 times 21. And I think that is all of them. 7 times 21, yes it is. Okay, the only one with a square number pairing there is this one. So I'm going to write it as a square root of 49 times 3. Square root of 49 times the square root of 3 is 7 root 3. I'm going to do 2 more slightly quicker this time. Alright, 72. Well, there are 2 different ways that I can do this. I'm going to split my page into 2 boxes, and I'm going to do it 2 different ways. You'll notice when you write out the factors of 72, I've got 1 times 72, 2 times 36, 3 times 24, 4 times 18, 5 doesn't work, 6 goes in 12 times, 7 doesn't work, 8 goes in 9 times, and that's all of them. Okay, you can see here that there are lots of square numbers that I could use to divide by. If I always list out the factor pairs and I always go for the highest one, I'm going to get to my answer straight away. So if I wrote it out as the square root of 36 times the square root of 2, I would end up with 6 root 2 quite easily. Square root of 36 times 2, I've written it as my 2 separate calculations, and the square root of 36 is 6, and root 2 can't be simplified. However, if I'd have picked a different one, let's say for example I picked 9 times 8, I've got the square root of 9 times 8, which is the square root of 9 times the square root of 8, which is 3 root 8. I would have to stop at that point and I'd have to evaluate, can I simplify that surd anymore? Can I simplify 3 root 8 anymore? Are there any square factors in 8 that could be taken out? Well, yeah, there are. 8 is 4 times 2 and 4 is a square number. So I'd have to carry on my calculation. 3 lots of 4 times 2 inside that square root. Notice again how I've left the 3 at the front without the multiplication sign because as much as possible I want to avoid it. I've still got that 3 there. Then I've got the square root of 4 and then I've got the square root of 2. And then I've got 3 times 2 because root 4 is 2 times the square root of 2. That gives me 6 root 2. I do eventually get to the same answer, but I've had to do 2 simplifying calculations, one of them to here, a second one to here. You might feel like if you did this method you've probably got to the final answer there, but you haven't. So I would always list out all the factor pairs and always go for the highest one. Don't rush into it. Okay, final one. I've got the square root of 80. Okay, so again, looking back at my list of factors, my square number, sorry, I know that one of these numbers is going to fit in. Well, it's definitely not going to be 81, so it must be something smaller. It's not going to be 64 or 49 or 36. It's not 25, because 25 times 3 is 75. What about 16? Let's list out all the factors of 80 and let's see. So I've got square root of 80, 1 times 80, 2 times 40, 3 doesn't work, 4 times 20, 5 times 16. Okay, well I found 16 straight away and I know there's no other higher square number that will fit in. So I'm going to write it out. I've got the square root of 80. I'm going to write it with my square number first, 16 times 5. Write it as a separate calculation. Oops. And the square root of 16 is 4. My root 5 stays the same. Okay, if you've got any questions again, please pause the video here and send me an email. Okay, so I've got about 5 more examples to go through with you. If I'm asked to simplify within a multiplication, I need to think about what steps I could do. There are 2 different ways I could approach this question. Because it's a multiplication, I know that I can multiply both of those things together. So this is method 1. I could make that the square root of 24, because 12 times 2 is 24, and then I could simplify in the normal way. So write out all the factors of 24, 1 times 24, 2 times 12, 3 times 8, I haven't seen a square number yet, 4 times 6. Okay, well I can see that 4 is a square number. I'm just going to check 5 doesn't work. No, it doesn't, so this is the pair I'm going to go for. Square root of 4 times 6, square root of 4 times the square root of 6, and then that ends up being 2 root 6. That's one way I could do it. Not necessarily the most efficient, but that is one of the ways. Another way that I could do it is I could try and simplify anything that's not simplified yet. So I could try and simplify the root 12, and then I could multiply it by the root 2. So let's try that instead. So I'm going to leave the root 2 where it is, and I'm going to try and simplify the root 12. Well, I already know that 4 is a factor of 12, and that's the highest square one there is. So I've got root 4 times 3 times by root 2. Then root 4 times root 3. Still got that times root 2 there. 2 root 3 times root 2. When I have a surd multiplied by a surd as 2 separate things, I can multiply them within the surd. So it gives me 2 root 6. Root 3 times root 2 is the same as root 3 times 2, which gives me 2 root 6. Either one of those methods is absolutely fine to do. I would probably suggest the second one because it's a little bit more useful when we get into rationalising the denominator and things in one of the later videos, but you can choose. Okay, next example is involving a division. I don't think 90 can be divided by 8, otherwise I would try and do it this way like I did before and do 90 divided by 8 first by making it one giant 90 divided by 8 like that. However, because that doesn't divide nicely, I'm not going to do that method. What I'm going to do is I'm going to simplify the top separately, I'm going to simplify the bottom, and I'm going to see what I can cancel down from there. Okay, so 90 is 1 times 90, 2 times 45, 3 times 30, no square numbers yet. It's 4 times, no, 4 doesn't work, 5 times 18, still no square numbers. 6 goes in 15 times, still no square numbers. 7 doesn't work, 8 doesn't work, but 9 does. 9 times 10. Okay, that's got a square number in it. So I'm going to go for 9 times 10. 8 is a little bit simpler. Obviously 1 times 8, 2 times 4. That's the one I'm going to go for. So the square root of 90 I'm going to write as the square root of 9 times 10, again putting my square number at the beginning. Bottom one, I've got the square root of 8. So I'm going to put the square number at the beginning, square root of 4 times 2. Write them out separately. And then I'm going to simplify this to be a 3 root 10 on the top and 2 root 2 on the bottom. Again, using my rules of surds, I know that I can, if I've got 2 divisions of surds on top of each other, I can just write it as root 5, and then I've just got the 3 over 2. I'm going to leave that as it is. 3 root 5 over 2. Okay, 3 more examples to go through, and then I'm going to give you some questions to practice, and that will be the end of this video. Next one is root 75 times root 28. Okay, so again, I could multiply them together like I did in the previous example. I had root 2 times root 12, which gave me root 24. However, 75 times 28 is a massive, massive number. And I think I'm going to struggle to find square factors of that a little bit later on. So I am going to separate them, and I am going to simplify them first before I do any of the multiplication. Okay, so just to one side, I'm going to try and simplify root 75. Sorry, just move that way. I'm going to try and simplify root 75. I already can spot that 25 goes into 75 3 times. I don't think there's going to be a higher square number that fits in, but I could list out the factors if I wanted to. The more you do of these, the quicker it is to spot the factor pairs that you need to use. Okay, so I know that that is 25 times 3, which is the square root of 25 times the square root of 3. So over here, I'm going to write this one as square root of 25 times the square root of 3 for my first number. I also need to simplify square root of 28. Well, 28, if I list out all the factors again, I could list out all the factor pairs, but I know that 4 and 7 go into 28, and 4 is a square number, so I'm going to write that out. Square number first, 4 times 7, separate it out. Okay, so then I'm going to move back to over here, and for my second number, I'm going to have root 4 times root 7. Well, the square root of 25 is 5, and the square root of 4 is 2. Okay, now I've got some numbers without a surd, and I've got some surds. So I'm going to multiply the numbers together. 5 times 2 is 10, and I'm going to multiply the surds together. Square root of 21. 21 doesn't have any square factors, so it's as simple as it could be. Okay, 2 more examples to go. This one, I've got 4 root 50. Don't forget, if I have a number in front of a surd, it means they are being multiplied together. So I'm going to write it out as 4 times square root of 50. Seems counterintuitive to do that, but it's just to remind me that that's what that multiplication means. I'm going to try and simplify root 50. Same as before, I know that 50 is has a factor of 25, so I'm going to write it as 4 times 25 times 2. Writing it out again, 4 times square root of 25 times the square root of 2. That's just separating this bit out into 2 calculations. 4 times 5 times the square root of 2. Well, 4 times 5 is 20, so it gives me 20 root 2. Final one. This time I've got basically the same as above, but I've got 2 of them being multiplied together. So I'm going to check, can this one be simplified? Well, root 2 doesn't have any square factors, so that one's going to stay the same, but I'm going to write it as 5 times root 2. 4 is going to stay the same because it's just being multiplied by the root 27, but root 27, I know that that's got a factor of 9, so I'm going to write that as 9 times 3. keeping going, I've got 5 times root 2 times 4, then I've got times root 9 times by root 3. Looks quite complicated there, but if I just circle all the numbers I've got 5 times 4, and I've also got root 9, which is 3. 5 times 4 is 20, times 3 is 60. So that there is the same as 3. Then I've got root 2 times root 3, which is the same as root 6. Okay, that is all of my examples. Again, please do email me if any of those did not make sense. The technique you are looking to apply is thinking about which square factors do I have. Can I select the highest? Don't forget, it's not always going to be that there's only one square factor. There's probably quite a few. You need to identify the highest one and simplify. There are 16 questions on the screen. Zoom out a little bit. 16 questions now on the screen. Twist that a little bit so you can see it. 16 questions now on the screen. Please pause them and have a go at all of them, and then I will shortly be putting on the answers. Okay, so the answers are now there. You'll see them all down the side. Please check them, self-assess them, and if you have any questions, again, please do email me. Thanks.